There are very few things that make me happier than being in the middle of nowhere on a dark, quiet, cloudless night, just looking at the sky, admiring the array of stars above me, being at peace with nature. And one of the things I do appreciate is being able to get into and out of that situation relatively easily. Obviously, it's nice to do a long hike once in a while and be there in nice warm clothing, but sometimes I want to drive a long way. And I want to have good physical shelter. And that's one of the reasons the van is here, right? It provides transport, it provides protection against wind and rain and cold. But also, part of it is have a bit more luxury, to have water, to have food. And of course, sometimes you want to bring light into that dark, cloudless night because you just need to brush your teeth. So this is about how I brought electricity into my van build. Hello and welcome back to the van build. And as you can see, things have progressed a decent amount. There's some walls in, some fabric trim, there's some upper cabinet framing among other things. And at this point in the van build, things are kind of starting to become all rolled up into one. It's very much the case of like, well, I have to do framing and trim and electrical and plumbing and other things all at the same time, just because of the order of getting stuff behind other stuff. So for example, here with this nice big white wall, that had to go in before the upper cabinet framing here went in, because it kind of slides down that slot. You can't slide it down if the framing's in there. So this is kind of becoming a sort of everything's happening at once thing. And I probably switch to doing videos just of updates at some point once I've got past a few more of the basic things. So this time is electrical, next time I do gas and water plumbing, and then after that point, probably more of a general updates as I do a lot of the polishing, trim, installing the countertop here, that kind of stuff. So that's kind of how things are going to evolve. But today we're going to focus on specifically the electrics. Electrics are the first of the 3 utilities I put into the camper van. It's still not 100% complete. It's about, I'd say, 90%. I'm filming this now because I'm going to have to start closing up all this box down here. I'll show you in a second as I frame and trim around it. And so now is the best time to film all the internals. And then I'll probably come back and talk about some other things later on. But yeah, it is, you know, of the 3 utilities, you know, electrics, water plumbing, gas plumbing, it's the one I'm least scared of because I probably understand it the most. I've done electrical stuff my whole life. It kind of runs in my family a little bit. And so while there is a lot of respect to be had for the danger that things can bring, a lot of it being 12 volts does help the safety aspect. And also I just understand a lot of the risks and I overbuilt a lot of it. So that's kind of the way things go here. So before we dive into the electrical system and look at all the pieces in there, I want to quickly start off by explaining the 2 different voltages I'm running in the van. So obviously the van, like every other vehicle, comes with a 12 volt system. Most RV and camping equipment and even marine equipment is also made to run off 12 volts. So it makes sense to have 12 volts be sort of the primary electrical system in the van. The water pump, the fridge, even the water heater, all those things just run off 12 volts and it's easy and there's no sort of conversion loss involved. However, I have some few other things that run off 110 volts, which is the standard mains voltage here in the US. Things like laptop chargers, things like maybe even a microwave or even an induction stovetop. I'm not going to use those necessarily, but I want to have the ability to run them. And so for those, as you can see here, I have your standard US electrical outlet, and I have 110 volt wiring running throughout the van as well as 12 volt wiring. And you might think, well, you know, how different can it be? Very different, it turns out. In terms of a reference point, let's say you're trying to carry, you know, about 2 kilowatts. Roughly what it takes to run, let's say, an induction stovetop at full power. If you're doing over 110 volts, you need a cable about this big. This is American wire gauge 14 stranded cable. It's a bit thicker than you might otherwise spec, but it can take a decent amount of amps and power and it will do pretty well. And as you can see, it's quite flexible, easy to run through nice small spaces, works really well. However, if you want to run the same amount of power through a 12 volt system, you need these. These are American gauge 2 cables. Now for reference, both these cables will take about the same amount of power. The problem is, of course, in 12 volts, the voltage is so much lower that the voltage drop across the cable is much higher. And so the resistance heats the cable up and makes it melt. So you need much, much thicker cables like this. So the resistance is much lower, so it doesn't melt when you get all the same level of power through it. All of this much better explained by somebody else. Just giving you an idea of why in a minute you'll see some really thick red and black 12 volt cables and some really thin green, white and black 110 volt cables. That's because that's just how it works. The trade-off is 110 volts, much smaller cables, much bigger electrocution and arcing risk. 12 volts, much lower electrocution risk. It's very hard to electrocute yourself, but please don't try it. Much lower arcing risk, but much higher melting and heat damage risk, because that's kind of the trade-off you make. So that's kind of the background to the systems I've got going here. Let's dive into the actual electrical cabinet down here and move the camera, and I'll start explaining what all the different pieces of it are. So here we are in the little electrical system area in the van. Normally this is going to be a seat. There's going to be sort of a base for seat here, and the back's going to go here at an angle. And there'll be a wall here, which is why I'm filming this now before I put the wall in. That's the next thing I'm doing. But let's go through sort of the main components and name them, and then talk about all the systems involved. So first of all, just off camera here, you can see kind of one of them down here. There's a pair of big lithium iron phosphate batteries. Those are power storage, obviously. This big blue box is an inverter charger. This here is the solar charger. This here is a bus bar. This here is the alternator charger. This is a battery monitor and sort of battery shunt. This is the battery isolation switch. This is the main DC fuse block. And this is the main AC breaker box. So those are all the components. What do they do? Well, let's start with the batteries, right? So batteries are the heart of the system. Essentially, they're storing all the power. Now, you've got a couple of choices here. You could use your standard lead acid batteries that a lot of cars still use. They're fine, they're cheap, they're really heavy, and they do not like being drained below, half charge at best. And so they don't make great leisure batteries for a thing like this. I want batteries I can use all the capacity of. I want ones that aren't massively heavy and preferably don't have acid or weird gases off-gassing from them. So these are lithium batteries. They're not sort of lithium ion batteries or lithium polymer batteries you might find in phones. They're lithium iron phosphate batteries. There's an R in that ion. There's no R in the first ion. It's very confusing. But basically what the thing is, they can use all of their power. So each of these is 100 amp hours. You can drain them, and I have done, all the way down. They're perfectly happy with it. They're also about a third of the weight or less than the equivalent amount of storage in lead acid. So they're really good. Main trade-off is they're very expensive. They're about $1,000 each. I have two here. There is physical space for a third right here, and the system is specified for a third as well. But boy, are they expensive. So at some point, I just spend another grand and buy a third battery and slot it here. But starting with two for now, because two is plenty, I'd say. The batteries then kind of feed into the bus bar. This is this big thing here. Behind this blue cover are two giant metal bars. That's kind of where all the power flows in and out and around through the system. So all these main pieces, so this, batteries, and this, they're all connected into the bus bar via big old connections, big thick cables. You can kind of see here, the inverter's got nice thick cables, the battery's got some nice thick cables too. And that's kind of just handling all the power demands and shunting power around the system to various places. It's pretty simple wiring. It's all in parallel. There's nothing particularly complicated about it. You just should basically shove all the chargers and the batteries on one bus bar and go figure it out. And they generally do, which is really nice. There's also some mega fuses in here. Very funny name if you ask me. Big old like 100 amp, 200 amp fuses to make sure that even for the big systems, if they short circuit, then something's going to blow and stop them, burning up or causing a fire. From the bus bar, it then feeds everything else. Let's start with charging. This here is the solar charger. So it's got two connections to the solar panels, positive and negative. They go up to the roof. And it then has two connections to the positive and negative of the bus bar. It just sits there and basically takes the solar panel voltage. It fixes it so it's the right voltage to charge the batteries. So you want about 14-ish volts, right, to charge a 12-volt battery, and then just sends it back into the bus bar. That's what it does. It monitors how full the batteries are from the responsive voltage, and monitors it and makes sure it sort of tapers off its charge as it gets out there. But all three of these chargers kind of doing the same job. Is what they're taking a power source, they're making it to the right voltage, and then dropping the voltage slowly as the battery gets fully charged. All three of them do that. So this is it for solar panels. Works pretty well. Tested it out in the winter sun here in Colorado, and in winter sun got 250 watts. So pretty happy about that. It can be even better in the summer, I presume, with the higher angle of the sun. So that's me good. We do get a bit more sun here in Colorado because there's just less atmosphere in the way. It's a mile less air, and it turns out a mile less air gives you a bit more ultraviolet radiation, and panels love that. That's solar charger. Secondly, alternator charger. So the alternator in the vehicle does make extra power. It will happily give you the extra power if the computer in the vehicle thinks it has some to spare. The transit's pretty smart. It will give you extra power up to a very decent amount, and it kind of monitors its own state of charge, and it gives you the extra power even after the vehicle's turned off if it thinks its batteries are got too much in it. And so there's a power positive cable from this all the way into the customer connection port of the Transit. It's where you're designed to pull power from. If you're a camper van or an ambulance or anything, you just pull power from there. It's where the vehicle will send it to you. Only a positive wire, which is very interesting because this is non-isolated. It shares its ground with this, and in fact this is grounded back into the van's chassis on one of the official grounding points. So what that means is the ground is the same in the entire vehicle. I could, if I was feeling very lucky, just run positive cables to everything and ground them back in the chassis immediately, but grounding improperly causes some metal degradation, so I generally don't do that apart from to the official grounding points, which are sort of behind plastic covers here in the back. So that's kind of the alternator charger. It's 30 amps, it's not a huge amount of power, it's pretty decent, but if you're doing like a 2 or 3 hour drive, you get a good amount of power out of that. And I can always upgrade, put 60 amps of this in. The place I'm drawing from will give me, I think, over 100 amps if I want to pull it out of that system. So plenty of headroom on the vehicle side to draw more power. And you can kind of see here, plenty of room behind this panel here to add more chargers and stuff in future should I want to. So that's that. Third is the big boy. This is the Inverter-Charger. Now, charging wise, this basically takes a shore connection. So if you're in a campground, often you'll have little sort of electrical outlets you can plug into there. Here in the shop, it's just sockets on the wall. I'm just running a big long extension cable into the wall and plug in there. It takes that, and in charging mode, it will convert it down into your requisite charging voltage and then send it back into the bus bar to charge the batteries. By far, this gives you the most charge. It charges about 1.5 kilowatts of power, which compared to the hundreds of watts of these two is significantly more. But it pushes it down, charges the batteries nice and fast. It's about 3 or 4 hours for a full charge, I think I measured, so it's not too bad. And that's kind of its job in charging mode. Now, moving off of charging to the inversion mode, it also inverts power. So when you are plugged into shore power, it will also pass through that 110 volts AC power to its AC output, which goes into this breaker box. We'll talk about that in a second. But when you're not on shore power, it will then invert the 12 volt system here up into 110 volts AC and also send that to the breaker box. The fun thing is it can flip between both of those without any interruption. When you plug it into the wall, it takes 5 or 10 seconds to check the power's condition, make sure it's nice clean power, and then you'll hear it go clunk and it will switch just immediately to using shore power and start charging. And if you go and pull the power outlet out of the wall, it will then go chunk immediately and switch back to battery inversion with no drop. It's very impressive. I do like this equipment. It is lovely. That's kind of one of the reasons you see here. All of this is blue. It's Victron equipment. I like Victron stuff. It's really nice. It integrates well together, good high level of quality, and it seems really smart. Like a lot of this stuff is built on to use on like remote sites in the middle of nowhere. So it works really well in a camper van like this. So that's the Inverter-Charger. We'll talk about the AC system in a bit, but the other thing with DC is we have this shunt here. The shunt is kind of measuring the power flow to or from the batteries, and thus gives you a good idea of what the system's battery charge is very accurately. It's good to within 1%, which is much better than like just measuring the voltage, because obviously the voltage drops when you draw things from it. And then finally we have the DC fuse block here. So this has normal sort of automotive fuses in it, and this just powers like the water pump is one of these, and then like the motorized awning will be one, the fridge is this one, and so on. And most of the 12 volt systems in the van run off this, including these little sockets here. There's some 12 volt sockets around the van. They're your standard sort of cigarette lighter style sockets. If you've got little USB chargers or whatever, you can plug those in there. So that's a DC system. And well, DC is good. I like it. But as I mentioned before, there's some problems you can have with power transmission and getting enough power through. So there's also an AC system here in the van. So you can see here to my left, not only are there these little black cigarette lighter sockets here, but there are also these normal American standard power outlets. They even have USB things in them, which is very nice because they're a few dollars extra at the store. Why wouldn't I buy them? And so the AC system serves two purposes. One, it obviously supplies these for convenience reasons, for like laptops and a lot of other things that just come, like my drone charger just has this plug on it, right? I want to sit there and make a custom 12-volt cable for it, or add a rectifier or something. So a lot of stuff just wants standard power, so that's there for that reason. It's also there in case I ever want to go to an induction stove here in the future. Induction stoves draw a good like 1.8 to 2 kilowatts of power. It's pretty severe, I would say. And so this is a 3 kilowatt inverter. All the cables and stuff here are specified for 20 or so amps of draw, and there are 15 amp breakers in this breaker box. So the whole AC system is built not only for convenience for charging stuff, but also for running big appliances off of. So obviously, being British, my number one concern is a tea kettle. Electric kettles draw over a kilowatt themselves. They're pretty severe. And so that's kind of the first use of it, but also small kitchen appliances, maybe like, you know, a slow cooker or something like that. Like there's many, many uses, a lot of them kitchen related to have a lot of power draw. So yeah, that's kind of what the AC system does. It comes out of the inverter. The AC cables go straight into this breaker box. This is what's called a main lug box here in the US. That means it does not have a main breaker. You just feed the supply side of the breakers directly. And so there's just two breakers in there. The driver's side breaker powers the driver's side circuits. The passenger side breaker powers the passenger side circuits. It's shocking, I know. And they kind of just feed everything in here. Both of them are 15 amp breakers. Both are GFCI breakers, which means that if it detects that, you know, someone's being electrocuted or something's going to ground, it would immediately cut the power off and just stop you, hopefully, hurting or killing yourself, which is a really nice feature to have. And yeah, those are kind of just wired in via standard 14 American wire gauge cables. Everything here is stranded cable, obviously, because you can't use solid core cable in a moving vehicle like this. America uses solid core cable in houses. I find that really weird. They just do it, but even in moving vehicles, they admit you have to use stranded cables. So that's all of that. So yeah, that's kind of the main systems. I will go and show you some of the sort of the wiring and stuff throughout the van in a little bit. One more thing though is this here. This mysterious black rectangle is actually the sort of monitor for the whole system. It gives you a little display of what's happening and where things are going. And that is powered by a thing you can't see behind here, which is Victron's Cerbo GX. It's kind of a big brains of the operation kind of thing. And that plugs in via communication cables to this inverter, to the battery shunt, to the solar panel controller, kind of brings all that together and gives you a little sort of summary screen. It's got a little touch screen where you can do stuff with it. It has a tank sensor input, so it's also wired into a tank sensor in my water tank, so it knows how much water's left. And it also has temperature sensors both inside and outside the vehicle. So it runs all that stuff for you. There's even a GPS thing in here, so it knows where the van is physically, which is super nice. It just has all the brains. It's one of the reasons I bought all Victron, is it all ties into this and lets me do things as I want to and monitor things remotely. I can even like log into my phone from home if I'm not here in the shop right now and see like, oh, how much battery charge is left? What's the rundown time? What's the power draw and all that kind of thing. So that's kind of a really nice kind of brains of the operation thing and really brings it all together, I have to say. So yeah, that's kind of all this stuff. One note before I do go and show you all things behind the wall is pretty much just talking about safety. Now, there's two different kinds of risk here. When you've got AC power like this, 110 or 230 volts elsewhere in the world, you have an arc risk, right? You can have those big arcs of like electricity jumping across stuff, and you can pretty easily electrocute yourself. GFCI helps, but it's not perfect. You should never rely on it. So that's kind of the big danger there. 12 volts, on the other hand, much harder to electrocute yourself, is technically possible, but like I could just sit here and touch the terminals and be fine. Don't do it though. But the big risk there is heat and fire risk. If you run too much power down a cable that's too thin, let's say I ran, you know, like a couple of 100 amps down this tiny cable here, it would just melt and get really, really hot. And these big, thick battery cables, they get very hot too. I have run the system under what I would call full load, which is I plugged it in and ran it at full charge, and then I flipped it around and ran an electric kettle off of it as well, and then used an infrared thermometer to just check all my sort of points, make sure they weren't too hot. These cables to the battery got warm to the touch. They got to about 30 degrees Celsius. That's fine, that's totally within spec and what I expect them to be, but it does show you the severe level of power of what's flowing through these systems, basically. So that's one safety warning. The other thing, of course, is water and electricity often don't mix. 12 volts on water is much happier. 110 volts on water isn't. And if you may have seen a previous episode, or if you're very eagle-eyed, the water supply to the shower, so the camera right now is in where the shower will be. And in fact, I can wiggle these pipes here. There we go, look, there's one of the water pipes. The water pipes of that shower, they are down here in the bottom of this, because the water tank is behind here, and the pump is behind here. They run through the bottom of this cavity and then into the shower. So I have directly mixed water and power. I have made this calculated risk because A, there is not a single join in these pipes anywhere near this electrical section. B, they are physically lower than any of the power cables in the section. So if you notice, all the power stuff here is elevated off the floor. All the connections are off the floor. You could flood up to, I think, 5 centimeters or so and not even hit a single conductive thing in this compartment. And C, it's all 12 volts apart from this, which has ground fault interruption, which will hopefully catch water splashes. If it ever gets, gosh, like that high, it would be terrible. It would never do that. It would flow out the van. So it's something to consider. I would have avoided it if I could have done, but I think given the situation, it's pretty safe. And you know, there's not going to be a huge amount of water flowing through here on a regular basis anyway. And if I ever need to have an emergency, there are shut-off valves to the water right behind this panel here. So yeah, that's this little section. I'll just go and show you some of the garage stuff and some of the cabling back there and what it looks like, and then I'll wrap up and talk about plumbing. So let's go to the garage. So here we are in the garage, and as you can see here, there's a few different changes. We'll talk about all that stuff in a little bit, but the key thing here is the electrical things I want to tell you about first. So obviously back here, you've got a lot of the behind the wall wiring for electrics. So you've got your sort of 12 volt DC wiring down here. The 110 volt AC is separate up here just to make sure it doesn't interfere too much. You've got standard US electrical boxes for all the outlets and stuff. And then for the 12 volt outlets, they're just like, you know, wired normally. Again, the electrocution risk is much less with 12 volts. They're much more exposed, whereas the 110 volt stuff is safely inside a nice plastic box. So that's all sort of how the cabling works. To my right here, we have the big old cable that goes to the shore power. This is probably about, I'm gonna say like 6-7 meters long. It just about reaches from the van to the wall of the workshop where there's a power socket, so I can plug it in and charge it. It will reach probably most campsite chargers or sockets, and if not, you can just shove a big old extension lead on that and do as you will with that as well. The last thing, of course, which is really nice for recording videos down here, is the lighting. Like, you may not notice this, but this is powered off the van. So I have LED strips embedded in this aluminium framing now. You can see it's quite a nice light under here. It's got a dimmer as well. You can turn it down and up in sort of 6 increments here. So that'd be really nice for loading and unloading at night and generally finding things down here. And also just a good pattern for how I'm going to do a lot of the lighting in the van in general. So lighting is one of the things I couldn't film yet, just because I wanted to film before I closed up that electrical box and I couldn't see inside it more easily. But these lights are in. We're going to have similar sort of lights in the sort of bed area under the cabinets up there. And then probably like some more sort of standard ceiling, little round lights in the main ceiling as well. So all those need to be wired in. Also need to wire in switches, obviously for all the lights. This comes with its own switch, thankfully, but most of the rest of them need separate switches. And then for a few other things, including this. So this is the electrical water boiler I mentioned. It is a switch I made because looking at propane appliances, there wasn't a great solution to heating up water using a propane appliance that wasn't, hey, you shouldn't use this inside, or hey, you can use this inside, but maybe it's dodgy and you shouldn't leave it on for very long. Not super happy about that. I don't want combustion products in the air I breathe. And so I switched to a electrical water heater, which is what this is. It is the biggest DC power draw in the van, I would say, apart from the inverter, obviously. And it goes straight back into the battery fuse box area back there. And the idea here is that like this, it's not very big capacity-wise. You can see it's like, you know, it's like 6 liters it's specified as. But what it can do is heat water, obviously heating with electricity very efficiently, because you can't really make it not efficient. But also it can heat water up to a very high temperature. And as I'll talk about next time in plumbing, it then mixes it down to a safe temperature. So you can have this at a very, very high, almost scalding temperature. And that way it can kind of, you know, get more bang for its buck, as it were, as it mixes down with cold water, and you get like, you know, double the output of cold water to hot. But all of that we'll talk about in plumbing. But the key thing is, that's the biggest power draw. It has a big old thick 10 gauge wire that goes back. That needs its own switch as well, obviously. You don't want to leave that on all the time. It's going to be a huge power hog just when you're having showers or washing dishes. So power switch for that, power switch for this green box, which you can just about see under here. That's the propane furnace. So that vents out through the floor, which is why I'm happy to have that in the van. But that needs power as well to run its fan and combustion systems and the spark igniter and stuff. And then also probably going to have a switch for the water pump, just so that if the tank does run dry, this thing doesn't sit there straining, trying to pump water that doesn't exist. So all of these will kind of have ancillary switches on that kind of shower wall that isn't in yet, so where the camera was earlier. There'll be switches on that wall to just isolate all these off if you want to. And the water heater's case, just turn it on when you need hot water. And yeah, that's kind of the most of the rest of the wiring is like running switches, running lighting cables up to the ceiling, running a few more power cables to where the awning will be, so I can have motorized awning power, and then running a few more cables to various other points. We're going to have 12-volt charging outlets in the upper cabinets as well, the ones that are kind of above the bed you saw earlier. Not going to run AC up there just yet, though I could, but we're going to run DC power up there, so you can like charge USB things or phones or laptops or anything overnight. USB-C charging laptops have really made that very viable to do just with DC. So a bit more wiring to do. I'll probably cover that in future episodes. Like I said, put it in and record clips of it. But yeah, most of the sort of backbone of the system is done, and it all works. You can see here, right? Like the van is not plugged in. It is lighting me. Not only this light here, but this blue fill light behind me. And this is running off the inverter right now. It's just plugged into that little electrical socket up there. So the van is self-sufficient in terms of power. Like I've taken it outside, the solar power works, the alternator works. Like at this point, it's a good little moving power station all by itself. And so I'm really pleased with that. So yeah, it's been good. And you know, electrics is the thing I understand the most. So that's been great. However, things I don't understand quite as well as plumbing. So next time will be plumbing. As you can see here, I have a decent amount of progress with it. We have some hot and cold supply lines here. This is the ones for the shower. We have some isolator valves and stuff too. There is a water pump, there's an accumulator, there's the boiler, there are mixing valves, and this is all just the water plumbing. There's also gas plumbing to do. I'll talk more about that next time as well. That's even more terrifying because water just makes things rot. Gas, explosive, not as good. So yeah, plumbing is my next thing. As you can see here, it's about 65, 70% roughed in. The shower lines right now just terminate in a plug. They don't go anywhere. The sink I kind of have assembled, but I've never yet put water in this system. So once this video is done and recorded and edited, my next piece of work is to basically fill this big old tank here up with water, let the water pump rip, and hope that nothing sprays water at me anywhere. That'd be a fun time. So yeah, next time we'll talk all about that, and hopefully I'll come to you dry and without any kind of horror stories about water spraying everywhere, and hopefully unexploded from gas as well. So yeah, that's going to be my next couple of weeks. So I'll go do that, and hopefully you are doing well, and I will see you for all the plumbing stuff next time.